Hello everyone, and welcome back to the next video here in our video series for inference on proportions. This video in particular is going to cover the one proportion z test. So the videos before this, we were covering confidence intervals. This video now, we're going to move into hypothesis testing. Now, one thing that's important for you all to understand at this point is that these videos are meant to serve as a quick review of the big picture basics of each of these topics. And so to delve into the more theoretical things of how hypothesis testing works and why certain things are the way they are, that is not really the purpose here. This is meant as a quick recap of the important things you need to know for the exam and the important things that you need to write on the free response questions in order to get credit. The theoretical things, I can make videos that are 45 minutes to an hour long about those kinds of things. But for right now, this is just serving that purpose of the really quick review of the mechanics and some of the theory behind things if I think it's going to be important and potentially be tested. So let's jump right into this video here and talk about the one proportion z-test. So the big idea here is that we live on the distribution of the null hypothesis. So if you remember from class here, right, we have this distribution here of our null hypothesis. And if for some reason, in this case, our sample value falls into a certain region, right, this being our p-value, if that p-value is less than your significance level, we reject our null hypothesis. Remember, you never accept the null hypothesis. I will faint on the spot during the AP exam if you write that. I will faint in the middle of my classroom. I will just know, I have a sixth sense, it will happen. Right now, on the flip side, if our p-value is greater than our significance level, we do not reject. So those are my two options, right? We're looking at our p-value in comparison to our significance level. And so, generally speaking, hypothesis tests help us to make a conclusion about our population parameter. The thing that's important about hypothesis testing as a whole is that, very similar to confidence intervals, it's never going to tell you what the proportion or what the mean is. But it will tell you if it's greater than something or less than something or not equal to something. We won't know what it is, but we'll know what side it's on. And so the idea is we have an initial belief. We take a sample that we hope is representative from our population, and we see where that sample falls on the sampling distribution of the null hypothesis. And if it's far enough away from the middle, we can say that that's evidence that the true population parameter is different than the initial belief. It is all based on that null hypothesis. And then we take our random sample that's large enough and we see where it falls. It's that straightforward as far as a big picture idea of hypothesis testing. Where does my sample fall, assuming my null hypothesis is true? So, let's talk about our new acronym. Now, most importantly here, a one proportion z-test is used when we're testing for the value of a population proportion. Our new parameter, or sorry, not our new parameter, our new acronym is HAT North Carolina, or Harry and the New Cat, or how about them Nebraska Cornhuskers? Now again, the H stands for hypotheses. The A stands for assumptions, which is going to be slightly different than our confidence intervals. A very small, slight difference, but slightly different. This T is the test. The N here is still numbers. The difference with numbers in this acronym versus panic is that here numbers is not optional. You need to list these specific numbers here. And then this C is our conclusion. Right? This is our reject or do not reject. deal. So to take a look at this, right, let's actually take a look at an example here. So we have boxes of a certain cereal brand, blah, 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 and we have a total of 11 vouchers for free video rentals. This is how you know this question is old. This is like when Blockbuster was around. 11 vouchers for free video rentals out of 65 total, right? And then based on this, we're looking for, is it less than 0.2? So for my hypotheses, my null hypothesis is that P equals 0.2. My alternative is going to be what I'm trying to show here, that P is less than 0.2. Remember here also, your null is always written as an equal to statement, and your alternative is always written as an inequality statement. What's important here is that we still define P as the true proportion of cereal boxes with these vouchers in them. It is still important here to define your parameter. Now, when we get to our assumptions, the first one, we still need a random sample. That's still important. The problem said so. So we're good. The change with our CLT condition is that no longer are we using the sample data like we did with confidence intervals. We need to use the null hypothesis value. So it's n times my initial assumption greater than or equal to 10, and n times 1 minus my initial assumption being greater than or equal to 10. It's no longer the 11 from the problem, it's going to be using the 25%. So this is 65 times 0.2 greater than or equal to 10, and then 65 times 0.8 greater than or equal to 10. That is true. 65 times 0.2 is 13, which is correct, and that makes this 52, which is also greater than or equal to 10. So I am good to go. For my test, this is a one proportion z-test. And now for my numbers, here what I need to do is I need to get the actual test statistic, right? What comes along with that is my p-value, and these are the most important things. Now, if you had a significance level, which I believe this problem did, actually no, this problem did not. If we had a significance level, we would list that here. The standard significance level is 0.05. Right? Now, for this particular problem, I do not have a calculator in front of me at this moment in time, but I can go on the internet and get these numbers for you very quickly. So if we do that here, right, on your TI calculator, what you would do is you would get under stat and then tests, and then you would plug in the numbers that you have here. So for me, this is my 0.2. I have to get 11 out of 65 as a decimal, which in this case is this number, which is a very long number, and my sample size here was 65. And now I can calculate this. And so here is what I get in this particular case. I get a test statistic of negative 0.62 and a p-value of 0.268. Now, based on that, one thing that I've told you guys for a very long time, if you are not given a significance level, that means that no matter what, your conclusion is going to be the same. So it either means that your p-value is going to be very large, or it's going to be very small. And so in this case, for my conclusion, we would say as p equals 0.268 is greater than any alpha, we do not reject the null hypothesis. there is not evidence to suggest that the true proportion of cereal boxes with vouchers is less than 0.2. What's really important about your conclusion here, the first sentence is always reject or do not reject. The second sentence is always about your alternative hypothesis. So I hope that was helpful as a quick overview of our one proportion z-tests. I'll see you guys in the next one.